Hello and welcome to TGIS 311 Maps and GIS. This is day 9. The link on the first screen here is a map that's very recent. Saw it in the news on 22nd of May. Several new countries have now recognized Palestine as a state, and I'm not going to get into the politics of it and which is right and which is wrong, but I just thought I'd mention that all of a sudden there's another map that was likely made in the very recent past, such as the past 24 hours, to correspond with this news. And we'll take a look at that in class. Today's tentative plan, as always, class will start, announcement, maps of the day. We just did one from Al Jazeera News. Lectures and demos. Today it's regarding rasters and sharing. And then you'll begin your labs 7, 8, and 9. As mentioned previously, lab 7 is a normal lab. Labs 8 and 9 are very short. You should have plenty of time to get those done in class next week, or you can get a head start on them even sooner. You've been using vectors for the most part in 311. This week you'll start using rasters. You'll do some raster analysis after downloading the rasters and some vectors all on your own. Just a couple of announcements. The GIS certificate applications are open. There are still plenty of bonuses for you to complete to earn the grade of your choosing. There are extensions, so to speak, through June 5th, so you have plenty of time to submit everything. There is a data issue with Pierce County, and what I'm suggesting you do is download the data in a geodatabase, and that's spelled out clearly in the lab. And last reminder, there are just 2 more classes today plus 1 more. You have a regular lab and 2 short labs. This great quote is from a post which used to be called GIS Lounge. It's now called some other entity. I think it's Geography Realm. But GIS is more than just software. People and methods are combined with geospatial software and tools to enable spatial analysis, manage large data sets, and display information in a map or graphical form. And this was extracted in part from a 1999 GIS Lounge post by Caitlin Dempsey, and you can find that at gislounge.com. I also want to point you to wajissa.org to make sure that you've signed up for the GIS conference. It is free for you if you follow the procedures through UW Tacoma. And this is Geography Realm. It used to be GIS Lounge. Everything was merged together. And this is, again, is where I found the quote from Caitlin Dempsey from the previous slide. Just to refresh and go back to days 1 and 2, what is GIS? I'm repeating this for emphasis because we've covered quite a bit in the past 8 and 9 weeks. A GIS, or Geographical Information System, is a system designed to capture, store, manipulate, analyze, manage, and present all types of geographical data. The key word to this technology is geography. This means that some portion of the data is spatial. In other words, data that is in some way referenced to locations on the Earth. Coupled with this data is usually tabular data known as attribute data. Attribute data can be defined as additional information about each of the spatial features. A Quick example of this, we could use schools. The actual location of the schools could be a point or a polygon, being the spatial data, and then additional data such as the school name, level of education taught, student capacity, etc. would make up the attribute data. And it's the collaboration or partnership of these two data types that enables GIS to be an effective problem solver through spatial analysis. And on the bottom left of this slide, depicted some rasters for you. The top left would be a DEM, which is a digital elevation model. The green and yellow and red is a slope. You'll be creating one of those. There's an aspect in the very bottom left of this page. The gray is an hillshade. You have used a hillshade in GIS 311. And then the last one, if you're a hiker, you probably recognize this as contours, although these contours are symbolized. Instead of just lines, there's actually some symbolization within the colors. In looking at vectors and rasters, neither is superior. As you recall, vectors are points, lines, and polygons, and rasters are cells of equal size, and they represent or could look like a JPEG if you zoomed into a JPEG or a photographic images. Each of these data types has their own strengths and weaknesses. In some cases, such as Lab 7 this week, you'll utilize raster data for a while and then convert the raster into vector data because the tool required to perform our required analysis only works on vector data. There's a plethora of raster functions that are available and tools. These are some that you don't need to worry about right now, but you will moving into autumn and spring and future quarters if you go on to the GIS certificate. Such things as map algebra, distance functions, Boolean overlay, density analysis, interpolation, neighborhood statistics, zonal statistics, resampling, viewshed analysis, and then of course your interesting topic or project will likely use some amount of raster data. We probably will not use just vector data. Some things to remember in the lab. If you're asked to build pyramids, particularly for the Tacoma DEM, you will build pyramids, and what you'll probably have to do is A, never check, always use this choice, because you always want to make an informed decision, and you'll need to click on Learn More About Pyramids. Depending on the type of data, you'll use either bilinear or some other form of building pyramids. And that can be seen by clicking again on this blue link, Learn More About Pyramids. We usually never use any compression method, so you can just say no compression or use lossless compression. So here are some rasters. This is a digital elevation model symbolized in a couple different ways. This is digital terrain data covering most regions of the United States. It's available on the USGS in digital elevation model format on the U.S. Geological Survey, and that's where you'll download your DEM for Lab 7. From that digital elevation model, you're going to create a series of other raster models. In this example is a slope. A slope can be a decimal or a categorical representation. You will this week reclassify or convert from decimals to categorical. So your values will go from the values on the left to the values on the right. It's a little bit easier to understand if you categorize the data in the format on the right rather than the decimals for our purposes. And you'll understand that more when you get into the lab. There's a link on the on the PowerPoint slide if you'd like to read more about slope. A different raster is aspect. The aspect tool identifies the direction of downhill slope faces. The values of each cell in the output raster indicate the compass direction of the surface faces at that location. It is measured clockwise in degrees from 0, which is due north, to 360 degrees, again due north, coming full circle. Flat areas having no downslope direction are given a value of -1. You will see in the buffer areas of the water that there is a funky design in the gray portions of the water. That's our buffer, and there's no need to worry about that. That's just an artifact. And again, there's a link on your PowerPoint so that you can go to the aspect to learn more about it. You've used hillshades in the past. This is another hillshade. The image on the far right is a hillshade and a slope on top of it with some transparency so that you can see the hillshade below or through the slope. The image in the middle is a sink. It's not really a hillshade, it's inverted. If you look carefully between the middle image and the image on the left, you'll realize that it's been inverted and it should be fixed. So rather than all of the hills being depicted as hills, it's actually depicted as a sink. There's a link on this slide to help you learn more about hillshade. So this again is a hillshade visual. It creates a shaded relief from a surface raster by considering the illumination source and angle, source angle and shadows. And the last of the examples, these are contour lines and the visual options of them. Contour tool creates a feature class, which is actually a vector rather than a raster, from a raster surface. There's a lot more to read on this if you go to the Arc Pro help. And again, these are just some samples that you'll be looking at in Lab 7. There's actually an entire list of different types of rasters that can be used for multitude of analyses for data analysis. And then this last image is literally quite that. It's just an artsy image to help me encourage you to be creative in your work. I've applied a unique symbology or color scheme to this contour just to create an interesting looking backdrop of Tacoma. If you'd like to submit something to have me present in future quarters, you can submit probably by email just a JPEG, a PNG of something from this lab if you'd like me to include it in the PowerPoint. I'd be happy to show off your work. What do you need to know for Lab 7? Particularly, you're going to learn how to download raster data and work with raster data, project raster data. You're going to reclassify some raster data using spatial analyst tools and convert one set of grid values to another, and that's what these helpful screenshots are depicting. You're reclassifying the data from what looks like about 9 different classes plus no data into just 4 different classes. And based on a widely recognized and accepted terminology for steep slopes or moderate slopes, we'll use those figures to create a much easier to understand visual. Again, a refresher, vector and raster, neither is superior. Vectors can be coverages, shapefiles, and feature classes, so that's points, lines, and polygons. And rasters are data files containing cells of equal size. If you zoom in, you can see the small cells. Although those cells may be rather large, they could be 30 by 30, so that's 30 feet by 30 feet in some cases. And it looks like a JPEG. If you were to zoom in, you'll see the little pixels, so to speak. This slide depicts the 3 different kinds of vectors in 3 different formats. You've been using shapefiles and feature classes. You have not used a feature data set yet, but you will in quiz or lab 9. And that's where you can see in the middle image on the left, there's a sample FDS. That's a feature data set. So you will learn about that in the coming days. But for right now, you can still recognize these gray versions as points, lines, and polygons of, as a feature class within a geodatabase. Here, they happen to be within a feature data set as well as a geodatabase, but they would still be gray if they were only in the geodatabase. Vectors, as shown in the top left and over in the top right, they are an old format of data that aren't used anymore, and you probably won't run across them, which is why we're not using any in 3.11. But I wanted to show them to you in case you get asked, have you ever worked with coverage data? And a good answer for that in an interview would be no, they're not that widely used anymore, and we didn't need to use them in my courses. That's all you really need to say. There's probably no more coverage data out there for you to retrieve unless it's very old, and in which case you'll convert a coverage to a shapefile or a feature class and move on from there. You'd never utilize a coverage in analysis anymore. And then again at the bottom is the shapefile data. You've downloaded shapefiles from Canvas to use in your labs, and you can recognize those as points, lines, and polygons depicted in green. So green for shapefiles, gray for feature classes, and yellowish for coverages. On to the lab. In the lab, the main goal of this lab is to create a singular feature class consisting of all residential tax parcels located on a steep slope or located on steep slopes in Tacoma. Once you collect your data, it's about a 3-step process. And I write in here after you've completed the capture, store, manipulate, and analyze the data using our traditional definition of GIS. So let's just quiz you here as you're watching this PowerPoint or just looking through the slides. What do you create at the beginning? And hopefully you recognize that you'd create a directory. And then think, what else do you do? Well, you do your environment settings. You set the output geodatabase. You set the coordinate system for the data, etc. What data is needed? So if you're looking for residential tax parcels and steep slopes, what data do you need? So you're going to download that data, some from the USGS and some from Pierce County. One that you probably won't use in the analysis, but you may use in your symbolic or your final map would be roads. So that's why there's 3 pieces of data that you'll download from Pierce County. In step 5, you'll select out a singular city from the cities layer, and hopefully you remember, or that flashes in your head about you would data export features, because that's how you export a singular feature. We then would clip tax parcels by Tacoma, clip the roads, and then create a buffer around Tacoma of about, well, not about, but exactly 0.5 miles. You will clip the raster, and it's not called a clip, it's called extract by mask of your DEM, and then in using the buffer, by the way, and then you'll, utilize that data to create a slope. You'll then select the steep slopes, select the residential parcels, and then select by location. You're going to select residential parcels on steep slopes. And that's all you're doing in the lab. It sounds pretty simple. This slide spells it out for you. So feel free to pause and or take a picture of this so you have it, whatever works best for you. It looks like there might be something missing. Oh, step 13. Let me make that visible. No, there's not. There we go. So here's the previous slide, but I've filled in the answers for you. And we'll talk about this a little bit in class. So getting back to the hard part of the analysis, think about what do you need, and then the 3 things that we're going to select. And that's what we'll talk about in class. I'll do some demos. And coincidentally, on the right, this is the final answer to the lab. This is 100% perfect answer. These are residential parcels on steep slopes. So if you complete the lab and yours does not look like this, then you may have done something incorrect to mess up your data, or you may have just not completed the analysis yet. You may have a little bit to go. This is a little bit more descriptive visual. In this image, I have selected the steep slopes in Tacoma. You notice they are aqua blue. In the following image, I've selected the residential parcels within Tacoma. The next image shows residential parcels and steep slopes selected in this image. And then I've done the select by location. So these parcels on these locations become these selected residential parcels. And then once I get done turning off or clearing or deselecting the steep slopes and the residential parcels that are selected, I'm ended and export it. I end up with the residential parcels that were on steep slopes. So again, I end up with the residential parcels selected, and then I export data, export features to create a new piece of data and layer, and I end up with my residential parcels that were on steep slopes. Hopefully this was a good heads up for the Lab 7 of GIS 311. Again, this is the end, or now day 9, the end of day 9. Feel free to work on Labs 8 and 9. They are available in Canvas for you after you complete Lab 7. You will have plenty of time in class next week to complete labs 8 and 9 if you don't get started on them. Or excuse me, yes, 8 and 9 if you don't get started on them this week. I look forward to seeing you in class. Feel free to email me, use the discussion boards. And if I don't see you before the end of the quarter, have a great break. And I look forward to seeing you in another GIS class. Thank you.